Good morning and welcome back to Dr. Logic Awkwardly Does Logic. So if system T is not good for approaches to modality that involve things like obligation and permission, or even perhaps belief, where we want to allow that people can have false beliefs, then what is good for those systems? The next system that we're going to look at is system D, mnemonic for deontic, though it can also be used for doxastic notions, i.e. notions of belief. Deontic logic is actually something that has been studied for a very long period of time. Some of the earliest approaches to kind of non-alethic modal logics that you find in the early part of the Middle Ages. So around the time of St. Anselm of Canterbury was interested in questions of obligation and permission and how to understand this in a modal sense. However, modern studies of deontic logic generally are dated to the work of Georg Henrik von Wright. So much of the kind of formal development of modal approaches to deontic logic is due to him. Anyway, we need to get our basics in place. So what we have is the axiom D, which corresponds to the logic D, and that says that if something is necessary, then it is possible. So this is weaker than T in the sense that if you have a system that includes T, you can prove D. You don't need to have it as an axiom. And I will give just a very brief proof of this. So in system T, you can prove the D axiom very easily. First, write down the T axiom, which is that necessary P implies P. Then take the contrapositive of this so that we have not P implies not necessarily P. Then do uniform substitution, replace not P with P on line 2 so that we have not P implies not necessarily not P. Double negation on the antecedent gets us P implies not necessarily not P, and modal interchange on the consequent gets us that P implies possibly P. And then take a look at number 1 and number 5. Transitivity allows us to go from necessary P to possibly P. So transitivity 1 and 5. Now, this is in quite a bit more detail than we normally do our proofs, but I just want to show you sometimes it's useful to have a reminder of what it looks like when you spell out every single step. So if we have this axiom and we add it to K, then so this is logic K plus axiom D equals logic D. Logic K, axiom D, logic. In a typeset logic book, you can actually use different fonts to indicate whether you're talking about the logic or the axiom that characterizes the logic. This is much harder on a whiteboard. So just the difference doesn't really make a huge difference. Try to keep in mind that you don't want to identify the logic with the axiom, but also that most of the time logics are going to be named on the basis of their characteristic axioms. But what this means that you can prove the D axiom in system T is that just as T is an extension of K, it's also an extension of D. And in fact, these are all going to be proper extensions because you can prove more in D than you can in K, and you can prove more in T than you can in D. And we will see this in the next video when we move to looking at what are the models that are characterized by this logic. So once we focus our attention on this axiom rather than on this one, what do the models look like? So just to recap, system D is the system with this axiom. It is used for deontic notions of necessity and doxastic notions of necessity. There you have it. this is what you need in a positive sense. If T doesn't work for these sorts of notions of necessity, this is the thing that does. Next time, we will talk more about the models. We'll probably prove a few theorems. Don't really have much more to say about D, but hey, it's another system. Until then, take care. See you later. Cheers.